So this is a CubeSat. Whoa. But this is a FemtoSat. So tiny, so tiny. So both the CubeSat and the FemtoSat are really like attempts at making a standard form factor to drive the cost of space satellite deployment down. A little bit like shipping containers. So like before shipping containers, cargo ships used to have their cargo just hauled on in various random quantities, and it would take ages to pack the ship and get it all ready to go. And as I mentioned in yesterday's talk, the cheapest price to get cargo to space at the moment costs $4,500 per kilo. So if you can put a bunch of satellites into one thing. So CubeSats have been around since around the year 2000, and their dimensions are 10 by 10 by 11.35 centimeters, and they can go up to a weight of maximum weight of 1.33 kilograms. And because these satellites are using off-the-shelf components, electronic components, those are miniaturizing very fast, and so rather than having a 10 by 10 CubeSat, you can actually now fit those things into a FemtoSat. And so the FemtoSat is a 3 by 3 by 3 centimeter cube, up to from a weight of like 35 grams to 100 grams, and it costs just $1,000 to launch from the International Space Station. And what's pretty insane is that in that 3 by 3 centimeter cube, it actually has propulsion, it has a solar panel, it has communications, it has imaging, and you can like customize it and add your own things as well. So clearly the next step is going to be the 1 centimeter cube, little CubeSat things. I don't know what they'll call them yet. They should have called the FemtoSat microsat and then called the Femto one FemtoSat. And then disregarding issues with space junk and space debris, which is a really huge issue that's going to get worse. Just imagine like being able to deploy thousands of satellites in one launch really cheaply. So let's take that even a step further. Imagine trillions of these 1 centimeter cube satellites constantly mapping the Earth in every single spectrum you can imagine and acting like a swarm that you can access. Now, if you can cheaply deploy 1 billion satellites, say, really cheaply, and half of them fail, it doesn't matter because they act as a swarm, so it brings the risk down massively. So now imagine deploying these on other planets. Imagine if you could just do one launch and suddenly launch 1 billion little microsatellites around an entire planet, around Venus, around Mars, and it accurately maps it in real time everywhere. I just think that idea is awesome. Imagine billions of little satellites around every single planet in the solar system, mapping every planet in real time and feeding that data back to us. Wow. Snap your thoughts. Our future.